Hi guys, this is our last video of this unit. Let's talk really quickly about assessing normality. So we've talked about the fact that normality is a really special word. And so, it's nice to have a way that we can tell if something is truly normal or not. Now, I'll tell you that the best way that we're going to talk about is this thing approximately normal. And you'll notice I put that word approximately at the beginning. I'm not telling you that it is normal. I don't quite have evidence to say, yes, this thing is normal, but maybe it is approximately normal. It's good enough for us. Okay, so the best way that we're going to always say things, you're likely never going to say something is truly normal unless you are told specifically in the problem that it is normal. But you have the right to say that something is approximately normal. Okay, and I'll give you some tools today just to help you decide if something looks approximately normal. Okay, so again, the first thing, the best technique is just to use your eyes. Okay? And if we look at this histogram over here, does it look pretty normal? I mean, it's sure. Okay, I mean, it's got some lower peaks here. Maybe we'd want to see those ones a little higher. This is just called to sampling bias. Okay, we obviously didn't, we don't have every piece of information. We're looking at all 50 states, but it's approximately normal. Okay, it's good enough. So yes, it is good enough. We don't want to be too picky. Don't worry about little nuances like that. It looks approximately normal. We should feel okay with that. Okay. However, let's go ahead and look at some things that you could ask yourself if you weren't sure if this thing looked approximately normal. Okay, so a good question you can ask yourself is, does this follow the empirical rule? So if you remember what the empirical rule is, and anything that's within one standard deviation should be approximately 68% of the data if it was truly normal. Anything within two standard deviations should be approximately 95% of the data. And anything within three standard deviations of the mean should be approximately 99.7% of the data. Okay, so we're going to look at the empirical rule and see if it matches with these percentages over here. Okay. I don't know if your copy, mine had some weird numbers written over here. I think those just didn't get erased from a previous year, so you can just ignore those. It was kind of messy and hard to read on the printed copy anyway. Okay. Now I had already calculated out for us the mean and the standard deviation. So we really just have to calculate a couple things. Okay, I even put some of the numbers in here for you. So the mean plus one standard deviation, we know the mean is 8.68, I'm sorry. That number, this must be plus one standard deviation. So let's subtract off the 2.23. And so my bounds for within one standard deviation are between 6.45 and 10.907. So what we need to figure out is how many states out of 50 fall into this range. I'll let you pause the video. You're just going to go back up here. We're given all of the data. We can count and find the exact number of data points that fall within that range. All right, so you'll see here, I put the bounds in my green marker here. 36 out of the 50 states fell within that range. So I'm going to calculate out the percent. It's approximately 72%. Okay, it's pretty close to 68. All right, let's do the same thing for plus two standard deviations. So two standard deviations, I'll calculate that first, 4.46. I've already subtracted it from my mean, so I just need to add it to my mean here. We're looking for all the data points within this bound, so between 4.232 and 13.14. Okay, I'll let you pause the video and go count how many states fell into that category. All right, you'll see I have it up here in blue. So it's all except for the outer 48 of the 50 states. That makes 96% of the data falls within two standard deviations of the mean. That still looks pretty close to 95. I have not found anything concerning yet. Okay, I'll let you pause the video and calculate these last numbers here. You will need to find both the bounds and then the number of states. All right, so what we've got here is there's my bounds. It included all of the states, all 50, so that's 100%. Again, it's looking really close to my empirical rule. Remember, the empirical rule is not a hard and fast rule. It's just an approximation for what you'll find. So what I've seen here is using the empirical rule, I have not found any evidence that the data is not normal. Okay, and that's really the key. If we can find something that makes it not normal, well, then I can say it's not approximately normal. However, So far, it looks pretty normal. It follows the empirical rule, so we're going to be okay with it for now. Okay, so you'll see I mentioned that a little bit down here. We haven't found any clear evidence that the data is not normal. Now, there is another graph that we can make. It's called a normal probability plot. Okay, you do not need to know how to calculate this. And honestly, you probably won't need to make your own normal probability plot, although it's not a bad thing to know, okay? What I expect more from normal probability plots on the AP test is they would give you one and ask you to interpret what that means, okay? So what I've put here is I've explained to you how to calculate it in your calculator. So if you want to pause the video and go figure that out, you can read through my directions here and do that in your calculator. I'm going to go ahead and talk about what it means, okay? So let's just talk real talk here for a second. Real data almost always shows some departure from normality, okay? Like if we look back up at this guy, obviously this is not a perfect bell curve, okay? It's got a few, peaks and things that maybe don't look quite right. But what I want you not to do is I don't want you to overreact to just minor things, okay? And a normal probability plot should be approximately linear, okay? Actually, it should be pretty strongly linear. But I don't want you to freak out when you look at something like this. This is pretty approximately linear, except for this weird little curve right here. That's okay. Okay, don't overreact just to that weird little curve that's right there, okay? So when you're looking at a normal probability plot, you're gonna look for very obvious things. Okay, don't overreact. So let's look at these two graphs down here. Go ahead and zoom in on those for you. And if we just ignore the histogram for a second and we look at this normal probability plot, I've even put the line on there for you. Does that look approximately linear? I'm going to go ahead and say no way. So the data you can see kind of traces up here. Well, then it has a huge departure and it veers off in that direction. Okay, this is not linear. The blue line might be a little easier to see than the data. Definitely not linear. And actually, if you look at your graph, horribly skewed. Okay. So we have the most of our data over here. We've got some data over here. It's definitely skewed right. It is definitely not approximately normal. Okay. And maybe when I asked my question over here, would you say this data is normal? I probably should have written approximately normal. Okay, so I'll go ahead and add that in here. And I would say definitely not. All right, so if you're given a normal probability plot, that would be this guy over here. It's really just going to ask you to, make some interpretation. Does this look approximately normal? If it has a clear departure from the data, it is not. If it doesn't, for example, this guy right here, he's pretty linear. That means, you've got more evidence that it is approximately normal. But again, remember, we are not saying it is normal. We are saying it is approximately normal. We save that word normal for some very special cases. Okay, so that's just a really brief overview of ways to assess normality. And that's the end of this unit.